Welcome to Real Garage, I'm Andy. In this Quick-i-sode, we'll do a real gear comparison of the Multimatic 235 versus the Millermatic 255. We'll also do one of our real projects on a heavy-duty swing-out equipment stand. The Multimatic 235 is a MIG, stick, and DC TIG machine, while the Millermatic 255 is a MIG, pulse MIG only machine. I did this comparison because I believe the applications for the Multimatic 235 will be primarily MIG. The Multimatic 235 has a duty cycle of 60% at 170 amps, which makes it a nice replacement for the Millermatic 212 at a similar price point with the added capability of stick and DC TIG with the optional accessory kit. It's excellent for welding materials up to 3/8 inch and has the finesse to weld that delicate 24 gauge material. The Millermatic 255 has a duty cycle of 60% at 230 amps, which is ideal for heavier fabrication and light industrial production up to those 1/2 inch material thicknesses. The Multimatic 235 offers a dual running gear option, which includes the TIG accessory kit. The dual running gear can also be purchased separately for the Millermatic 255, which makes a nice package if you want to weld with the mild steel inside the machine and an external spool gun. Both machines accommodate multiple types of spool guns, and the Millermatic 255 can even run the AlumaPro push-pull guns. Both machines have the auto gun detect feature, which means you can pull the trigger of whatever gun you have connected to the machine and it will automatically change to those settings. Both have the heavy-duty aluminum 2-drive roll system and can accommodate 4, 8, or even 12-inch wire spools. Both come with a 15-foot MDX 250 gun, AutoSet Elite, and easy-to-understand operator controls. Let's take a closer look at each one. With the Millermatic 255, in the AutoSet mode, I can select my material and gas, the wire I put in the machine, and then the thickness of the material that I'm going to be welding. The machine puts me in a window for my voltage and my wire feed speed that gives me a pretty good weld, and I have the ability to fine-tune within that window. If I turn the AutoSet off, I have full range of control over my voltage and my wire feed speed. If I get into the pulse MIG mode using AutoSet, my volts will change to arc length, and I still have my inches per minute for wire feed speed. In AutoSet mode, I can still select my different material thicknesses. As you can see, as I tab up in thickness, my inches per minute will change. The higher you go on the inches per minute, the more power the machine will give you. On the Multimatic 235, the first thing I'm going to do is select the process that I want to use. So I have my MIG processes, I have a couple TIG processes, and a stick process. Tabbing through those processes will give you a hookup diagram on the front of the machine for a few seconds to make sure you have the machine hooked up properly, and it'll tell you also what type of gas to use. The rest of the screen is similar to the other Multimatics that we have. We do have the AutoSet feature where I can turn that on and off. Again, in the AutoSet, telling the machine what wire diameter I have in the machine and material thickness will put me in a range that gives me a good solid weld and gives me some adjustment for fine-tuning. Turning the AutoSet off, again, gives me full range of control of machine for voltage and wire feed speed. The other nice thing about the Multimatic 235 is that it has AutoSet Elite in all processes. So if I want to come down here to even stick welding, okay, it's going to tell me I have a cable error because I have the wire housing connected and I need to connect my stick stinger. Okay, I can turn the AutoSet on and now simply tell the machine what thickness electrode I'm using and the material thickness. And again, it'll put me in the amperage range that I need, plus give me that fine-tuning ability. If you're looking for a lightweight, portable, but robust welder in that 200 amp range, the Multimatic 235 MIG, stick, and DC TIG machine is a great choice. If you require a little bit more power and want the pulse MIG capabilities for heavier fabrication like off-road or even trailer manufacturing, the Millermatic 255 is the answer. Today's real project is another one of those that helps me solve a problem in my garage. My issue is I have a set of slip rolls that's extremely heavy, and I store them upstairs in my loft. And whenever I want to use it, I gotta drag out this folding arc station, which is actually the easy part, set it up, go upstairs, pull this thing out, which it weighs over 100 pounds, I'm sure, and put it on my lift, bring it down here and set it up, clamp it to this table before I can even use it. So my project today is to build a swing out heavy duty equipment stand that's gonna mount to one of my vertical posts in my shop. This way I can leave it down here, but when it's not in use, I can swing it out of the way against the wall and it doesn't take much room. So my material list for this project is gonna be a lot of this 3/8 thick plate steel, some of which I found at a local scrapyard. So this was drop off from somebody else's job, and I also got some of this plate steel here. This piece is really the only piece I had to buy. It is 8 inches by 36 inches long, and that's where the slip rolls are gonna mount to. I'm actually gonna drill and tap this and mount the slip rolls to it using a set of 5/16 bolts. Some of the other bolts I'm gonna use are 5/8 bolts for my swivel points, 1/2 inch bolts, I'm gonna use these to lock the plate in place once you swivel it out, and a set of 3/8 bolts to bolt the vertical support tube that braces it at the outside edge of the mount. I need some drills and taps. I've got a plumb bob so I can find my centers, and an assortment of wrenches, and of course my measuring tools. I'll be using a plasma cutter to cut these plates so that I can fit them to my vertical post. I'm gonna be using a Millermatic 255 machine that I got a chance to try out, and I'm gonna be pulse MIGging this project. Since the material is so thick, I think that's gonna be a pretty cool process. So my first step is I'm gonna take and measure where I wanna mount this to my vertical post. I know I want it to be about the same height as the folding arc station I'm currently using because I'm very comfortable with it in that position. So that's gonna be about 35 inches. So I'm gonna actually run it about 35 1/4. I also need to make sure I have enough clearance for the top base plate so when I swing it out of position that it can swing up next to the wall. So I have about 5 3/4 inches of clearance there. So I will be notching a corner piece out of the top and bottom swivel brackets, and the top plate will sit right on top of that. The bottom swivel bracket is about 4 inches off the ground. And once I mount that plate, all I have to do is measure my diagonal, and I'll be building a square tube support to go from the bottom swivel bracket to the end of the mount. And that will make sure it supports that piece where it's way out, because this is gonna be 36 inches away from this vertical post. So it needs something on the end to support it, all that weight. But when I swing that over out of the position when not in use, it'll slide up right next to the wall. I'm gonna be using this piece of drop-off as a template to mark where I need to cut this corner out so this top swivel plate can get welded to the vertical post. So the next step's kind of critical. I need to measure the pivot point of this top mounting base plate. This is the piece that's gonna get welded to that post. To figure that point out, I'm gonna measure diagonally from the corner of the tube, and I need to make sure that I put this pivot point far enough away so that when the base plate is in full storage versus full extension, that I have enough clearance for it to make that swing around the post. Okay? So I'm planning on making mine about 2 3/8 inches away from the corner. That gives me 1 3/8 clearance that I can work with for the top plate to mount. Now keep in mind, you got to put a weld on this plate too, and the weld's going to take up at least 1/4 inch to 3/8. So that means I'll be taking and drilling my pivot point on my top mount about 1 inch from the end of the piece. The bottom swivel point isn't as critical. It's gonna end up lining up anyway because I'm gonna drop a plumb bob through the top pivot point, which will determine my cut point for the bottom pivot point. But I'm gonna trace out one of these corners as well so I can plasma cut that corner out too. And remember, read and follow all labels and the owner's manual. I also took my grinder and ground off the mill scale on the plates and the posts where it gets welded to. That mill scale will add some contamination to your weld if you don't do that. So now I'm tack welding these plates onto my vertical posts. I'm going to be using the Millermatic 255 that I borrowed in the pulse MIG mode. I basically just set it on the auto set feature for 3/8 thick material. I'm then going to take my digital level and make sure that it's perfectly level both directions before I weld it in place. Now before I weld the bottom pivot plate to the post, I'm going to drop a plumb bob through the top hole and make sure that it lines up to the bottom plate. I'm going to make my mark there, and that's where I'm going to machine my bottom 5/8 hole. That way I make sure that the top pivot point and the bottom pivot point are perfectly in line. So after I got it welded in, I would need to double check and make sure that my clearance is still where it needs to be before I machine the hole in my swivel base up on top. So I'll machine that hole and it'll line up with this one. And I have to make sure that I'm at least 1 inch away from the weld. That's what I calculated it as anyway. And I'm actually almost 1 1/8 inches there. So that'll give me enough clearance on that side. And then when I extend my platform out to its full open position, I still also have to have that same inch clearance to the weld here. And I'm at about 1.16 inches. So I'm good. So my original calculations will hold out. I can go ahead now and machine my 5/8 hole in my top plate. After I milled my 5/8 pivot hole in my mounting base, I also milled 2 1/2-inch holes, which will be used for my locking bolts. These will be tapped into the bottom plate. Once I extend the table out to full extension, I will screw 2 of these into the holes, and that'll lock this into place so it doesn't move while I'm using whatever tool is mounted to it. So I mounted both plates, the top plate and my bottom swivel plate, to their mounts. I put my digital level on here and I will shim this up until it's perfectly level. Then I can measure for my diagonal support tube that'll go from the end of the plate to the bottom swivel plate. Now that I've got everything welded into place, I've extended it all the way out so that I can transfer punch these top holes to the bottom plate, which will be drilled and then tapped for my 1/2-inch locking bolts. So there you go. 1 slip roll mounted to a heavy-duty swing-out equipment stand. It swings out of the way for storage, easily opens up for where I need to use it, put my locking bolts in, and it's super sturdy. You could mount a vise on this, even a small drill press, whatever. The Millermatic 255 worked flawlessly. I used it in pulse with the standard auto settings. When I used it on the dissimilar thicknesses of the 3/8 plate and the 120 wall square tubing for the diagonal brace, all I did was split the thickness in half and set the machine at 3/16. Thanks for stopping by Real Garage. Next time, we'll install our frame connectors. do a real road trip over to see Vaughn Gittin Jr., and another one of my real projects.